Welcome to Prime and Composite Numbers, GCF and LCM. Let's go. The learning targets of today's lesson is learning prime numbers, learning composite numbers, learning GCF, and learning LCM. So today we are filled with definitions, so I need you to bear with me. Let's start. Let's start with a small topic at the beginning. Prime numbers. What is a prime number specifically and exactly? A prime number is a natural number that has exactly two factors. What is a factor? We will find out. But it has two factors, and the factors must be one and itself. Okay? So the factors of a prime number are one and itself. For example, I have some example for you. For example, 2, 3, 5, 7, 11, 13, 31, these are all prime numbers, which means that they have the factors of 1 and themselves. And I want to add two notes in this part. First is that 1 is the only number that is neither prime nor composite, because 1 has one factor, which is itself. In order to be prime, you need to have two factors, and in order to be composite, you need to have at least three factors. So that's why 1 is neither of them. And the second note that I want to add is that 2 is the only even number that is prime. Why? Because all the other even numbers, if they have the factors of 1 in themselves, they at least have one more factor, which is 2. And that's why 2 is the only prime even prime number. Any of them that you want to consider. So yes, this is prime numbers. Let's move on. We have composite numbers. Composite numbers are the natural numbers that have more than two factors. They're factors on 1 themselves and some other specific numbers. So a composite number can have three factors, like the number 4, which the factors of number 4 are 1 itself and 2. Or a huge number like 100, which has the factors of 1 itself, 50, 25, 25, 10, and so many more factors. So yes, this is composite numbers. Now there is another topic which is named factorization, which we will learn. What does factorization within itself mean? Factorization means breaking something into parts or separating it. Right? So it means that when you want to separate a composite number into its prime factors, then this is the factorization of composite numbers, as it's written here. In mathematics, when a composite number is written as a product of its prime factors, this process is called factorization. And we will have an example of factorization after finishing the definitions. This was it. This was our first topic, prime and composite numbers. Now let's move on and let's go for factors, multiples, GCF, and LCM. So at the beginning, what are factors and what are multiples? So factors of a number are its divisors, which are the multiplicative components of it. What does divisor mean? Divisor is a number that can make other number be divided. Do you understand? So it means that, for example, we will have an example and you will completely understand this topic. And also multiple is the opposite idea of factors, not area. Multiples are numbers resulting from multiplying two numbers. So they are basically divisibles. Divisible is a number that can be divided, that can be separated into parts, into equal or partial parts, right, by each of those numbers. And divisor is a number that can make other number be divided either completely or partially. If it makes the other number be divided completely, then the remainder will be 0, and if partially, the remainder will not be 0. It will be some other number. So yes, this is it for factors and multiples. Now let's have an example. 5 times 3 equals 15. This is a very simple example. But from here, we can learn two things. In here, 5 and 3 are the factors of 15, and 15 is the multiple of 5 and 3. And that's why I tell you that these two topics are completely the opposite from each other. So this was it. Now let's go and move on. What are GCF and LCM? Have you guys ever heard of these two topics? Because GCF and LCM, both of them can be very, very complicated sometimes. But if you find the exact way and the standard way to find them, then it will be a very simple topic. As I told you in the first lesson, that we need to use simplicity in order to learn mathematics, right? So GCF is an abbreviation. It stands for the greatest common factor, which means GCF, okay? GCF is the largest whole number that two or more numbers can be divided by. And in order to find GCF, we first state the prime factors for each number. For example, we want to find the GCF of 3 numbers, then we need to state the prime factors of each and every one of those 3 numbers. And then we write all the prime factors for each number into a Venn diagram, and then we multiply the prime factors in the intersection part. We only multiply the numbers within the intersection part, and then we will find GCF. What is intersection part? We will find out later. And our last topic is LCM. LCM is also an abbreviation, stands for lowest common multiple, and is the smallest whole number that is a multiple of 2 or more whole numbers. In order to find LCM, the 2 first steps are the same as the 2 first steps of GCF. You state the prime factors, you write them into a Venn diagram, and then in order to find the LCM this time, we multiply each prime factor in the Venn diagram. We don't care how many numbers are there, we need to multiply all of them in order to find LCM. And we're done. Now let's go and solve some problems. Okay, everyone. Now let's go and achieve 2 things in this exercise. Factorization, learn factorization, and find the GCF and LCM of 2 numbers. Because in order to find GCF and LCM of 2 numbers or more numbers, you need to first factorize each number. So let's go. For example, I want to find the GCF and the LCM of 2 numbers 30 and 42. So I will first go and factorize the number 13. So I will write number 30 in here, and then I try to find the smallest divisible of 30 that I can, the smallest factor of 30 that I can, which is 2. The smallest prime factor that I can find is 2. So I write 2, 30 divided by 2 is 15. Always try to find the smallest prime factor, okay? For 15, I cannot use 2 because it's not a factor of 15, but 3 is. So I can write 3. 15 divided by 3, it equals 5. And 5 is a prime factor within itself. So I can write 5 in here. 5 divided by 5 equals 1. In this column, we can find all the prime factors of 30, which are 2, 3, and 5. Okay, so this is how you factorize. It's very easy. So now, the prime factors of the number 30 are 2, 3, and 5, right? And if we do the same process and go with the same process, the prime factors of the number 42 will be 2, 3, and 7. So these are all the prime factors. Now let's go and draw a Venn diagram, as the steps and the process of finding those 2 tell us. So in order to draw a Venn diagram, I need to just draw 2 circles connected with each other. So I will name them the circle 30 and this one 42. Okay, and I will write the prime factors of each and one of them. There are 2 prime factors that are the factors of both of these numbers, which were 2 and 3, right? So in this part, which is called the intersection part, I write 2 and 3. And 42 had another prime factor, which was 7, and 30 had another one, which was 5. And now I can easily find GCF and LCM. I really recommend you to use this method to find LCM and GCF because it's very easy. In order to find GCF, we said that we need to multiply the numbers within the intersection part. So I need to multiply these two numbers, which are 2 and 3. 2 multiplied by 3, 2 times 3 is 6. So GCF of these two numbers is 6. And in order to find LCM, you need to multiply each number, every single number in this diagram. So in here, we have 5, 2, 3, and 7. We need to multiply all of them in order to find the LCM. So let's go ahead and let's multiply them. 5 times 6 equals 30. 30 times 7 equals 210. So the LCM of these two numbers, it turns out to be 210. Yes, and this is how we find the LCM and GCF. As you can see, GCF and LCM of these two numbers are very, there is a huge difference between them. And it's because the numbers are big. The bigger the numbers, the bigger the difference between their GCF and LCM. Thank you very much for being with me in this lesson. I truly enjoyed it, and this one was a fun one. Thank you. Sources page.